Hey guys, Mr. Milton here. Today we're going to talk about graphing systems of equations. At the end of this video, you should be able to explain what a solution looks like for a system of equations, and you should be able to solve a system of equations by graphing. Okay, let's do some vocabulary first. So vocabulary, a system of linear equations, and I'll just say a system, okay, is two or more equations together. Okay, and a solution to a system of equations is any ordered pair that makes all equations true. Okay, when we say ordered pair, we mean x comma y like a coordinate. This doesn't move anymore. Okay. All right, so here we go. To start off, we're just going to be given an ordered pair and asked if it's a solution. Okay, remember that if it is the solution, it means it makes both equations true. So we're given the point 3, negative 4, and asked if it's the solution to this system of equations. You might see them just stacked together. Sometimes there's a bracket here to say, hey, make sure you link these two. All right, so what we're going to do is we're going to plug in our values. 3 is x, y is negative 4, so I'm going to plug negative 4 in for y equals, plug 3 in for x, minus 7. So 3 minus 7 is negative 4. It makes that first equation true. Now, remember we have to make sure that it makes both equations true for it to be a solution, but we're off on the right foot. So now we do this again. 5 times 3 plus 3 times negative 4 should equal 3. So 15 minus 12 equals 3. Yes, that's true. So it works for both of these equations. So the point 3, negative 4 is a solution because the point is on both lines. Because it makes both true, we know that the point is on both lines. Okay, and makes both equations true. Okay, all right. So now in the second system, we are going to plug in negative 1, 2. So 2 for y equals 4 times negative 1 plus 6. Okay, so that is 2 equals negative 4 plus 6, and that is true. 2 does equal negative 4 plus 6, so it works for this first equation. We'll now do the same thing with the second equation. 3 times negative 1 plus 2 for y equals 1. So negative 3 plus 2 equals 1. It does not. This is negative 1. Does not equal 1. So it does not work for the second equation. So the point negative 1, 2 is not a solution. Okay, it is not in the second equation. Not on the second equation. Okay. If it were on the line in the second equation, it would make the second equation true. All right. So now let's get into the actual solving of this. So that's just us being able to check answer and seeing how that works out. But we're going to solve a system by graphing. And essentially what that means is we're going to graph two lines on the same graph. Okay, that's it. Okay, if the lines meet, that point of intersection is the solution. So let's see. First problem, pretty nice. They gave it to us in slope-intercept form. So y equals 1/2 x minus 5. So in order to start this first one, minus 5, 1, 2, 3, 4, 5. First point here. Our slope is 1/2, so it goes up 1 over 2, up 1 over 2, up 1 over 2. I could do that a bunch of times. I could go down 1 to the left 2, down 1 to the left 2. All right, and so that's the shape that we have there. Okay. Now, what we'll do is we'll do the second line. I'm going to get it into color so that we can see it pretty clearly, the difference. Okay. My y-intercept here is 3. 1, 2, 3. Going to have a negative slope, so going to go down 3 to the right 2. Down 3 to the right 2. Down 3 to the right 2. Okay. And with that, now I am able to draw my lines. I can see the intersection. You can really see the point of intersection right now. See if this is a good makeshift straight edge. Do this so there's no advertising. Okay. All right. there. Line through here. If I can get it all set up. Alright. Okay, so have both lines graphed. You see that they both intersect at this point. Okay, they intersect at the point 1, 2, 3, 4, negative 3. Okay, which point is on both lines? The answer is 4, negative 3. Okay, this is the solution to our equation, or to our system. Okay, the solution happens where both lines meet. Alright, number 2, second example. Again, we're given this first line in slope-intercept form. 1, 2, 3, 4. Our slope is negative 2, so we go down 2 over 1, down 2 over 1. I can keep doing that, and I actually will keep doing that. That way I can see my solution a little bit more accurately than if I just drew a line from the first 2 points I knew. Our second equation is not in slope-intercept form. It's actually in standard form. So you could graph in standard form if you choose to. I am going to change it to slope-intercept form. Okay, so to do that, I'm getting y by itself. I'm going to subtract 3x from both sides, plus 6, and then I'll divide by negative 2. And so y will equal 3 halves x minus 3. So 1, 2, 3. I'll intercept. My slope is 3 halves, so I'll go up 3 over 2, up 3 over 2. I can see my solution already, so I'm going to draw a straight line here through the points. Okay, one line there. Second line. Get that set up. There, something like that. Okay. And our points intersect, our lines intersect at this point, the solution being 2, 0. Okay, so this is our solution here, 2, 0. So essentially, we're just graphing two lines on the same coordinate plane. Where they meet will be our solution. Okay, so where do we find the solution to a system of equations on a graph? At the intersection of the lines. At the intersection of the lines. And that is the big picture. Graph two lines on the same graph. Where they meet is our solution. Alright. So, let's look at some special cases here. Here we're given our first line, 4x minus 3, y equals 4x minus 3, so my y-intercept's at negative 3, my slope is 4, so I go up 4 to the right 1, up 1, 2, 3, 4 to the right 1, I can go down 4, 1, 2, 3, 4 to the left 1. Alright, and so this is my first line. I'm just going to go ahead and try to make these with this. Alright. My second line, again, is not in slope-intercept form. I could use the standard form to find the intercepts, but just to show the point of what I wanted to make sure I show here, I'm not going to do that. I'm going to put it in the slope-intercept form. So 8x plus 8 divided by 2. You get y equals 4x plus 4. Okay? So now that's slope-intercept form. So plus 4, 1, 2, 3, 4. Slope is 4, so I'm going to go, could go up, but it doesn't have enough space. I'm going to go down 1, 2, 3, 4, and to the left 1. Down 1, 2, 3, 4, and to the left 1. Okay? And now as I connect these lines, or sorry, these dots, you should notice that not only do my lines not meet in this graph, okay, but they actually won't meet ever. Okay? There's no point where we see that there's a point on both lines. Since these lines never, since these lines meet, we'll just say nowhere or never, either one of those, okay, because it will never meet. Not just that it doesn't meet on this line, on this graph space that we have, but it'll never meet. We can say that this system has no solutions. Okay, and so you'll see that these lines were, look at our slopes, Our slopes were the same. These lines were parallel. We had the same slope and different y-intercepts. Okay? Alright, let's look at the second one. Okay, in the second one we have y equals negative 3x plus 1, y-intercept at 1, negative 3 is our slope, 1, 2, 3 over 1. 1, 2, 3 over 1, go up 1, 2, 3, left 1, up 1, 2, 3, left 1. Okay. Alright, so we have negative slope, it's falling to the right. Alright, so that's our first line. Draw the straight line through there, okay? And now my second line is not in slope-intercept form, so I'm going to put it there. I'll start by subtracting 9x from both sides. Remember, slope-intercept form means that y is by itself. That's why we've been doing that. Divide by 3 here, so y equals negative 3x plus 1. So, you'll notice here that these two equations are exactly the same. So which point is on both lines? All of them. Okay, since these lines meet everywhere, and a line will continue on forever, we'll say that this system has infinitely many solutions. Okay, or IMS. Okay, notice that these lines have the same slope because they were both negative 3, but they also have the same y-intercept. Okay, so you can't just stop and say, oh, they have the same slope, they have to be no solution. Make sure they have the same slope and different y-intercepts to be no solution, same slope, same y-intercept to be infinitely many solutions, because that will mean that all the lines, that will mean that both lines are essentially the same line. Okay, so here's a summary. If two lines have different slopes, that means they will intersect and have one solution. So we saw on the front side. Okay, where they intersect, they have one solution. If two lines have the same slope and different y-intercepts, the lines are parallel and have no solutions. And if two lines have the same slope and the same y-intercept, that means the lines are coinciding. Okay, that's the word that you'll see, coinciding or the same, and they have infinitely many solutions. Okay, so try it out, bring this back to class tomorrow, and tell me how many solutions this final system has. Okay, I'm not asking you to tell me exactly what the solution is, I just want to know how many. Okay, so how many solutions does this have? Alright, see ya.